Building automation is the automatic centralized control of a building's heating, ventilation and air conditioning, lighting and other systems through a building management system or building automation system (BOS). The objectives of building automation are improved occupant comfort, efficient operation of building systems, and reduction in energy consumption and operating costs, and improved life cycle of utilities. Building automation is an example of a distributed control system, the computer networking of electronic devices designed to monitor and control the mechanical, security, fire and flood safety, lighting, especially emergency lighting, HVAC and humidity control and ventilation systems in a building. BOS core functionality keeps building climate within a specified range, provides light to rooms based on an occupancy schedule in the absence of overt switches to the contrary, monitors performance and device failures in all systems, and provides malfunction alarms to building maintenance staff. A BOS should reduce building energy and maintenance costs compared to a non-controlled building. Most commercial, institutional, and industrial buildings built after 2000 include a BOS. Many older buildings have been retrofitted with a new BOS, typically financed through energy and insurance savings, and other savings associated with preemptive maintenance and fault detection. A building controlled by a BOS is often referred to as an intelligent building, smart building, or, if a residence, a smart home. Commercial and industrial buildings have historically relied on robust proven protocols like BOSnet, while proprietary protocols like X10 were used in homes. Recent IEEE standards, notably IEEE 802.15.4, IEEE 1901 and IEEE 1905.1, IEEE 802.21, IEEE 802.11 acres, IEEE 802.3 and consortia efforts like NVOI, which verifies IEEE 1905.1 compliance, or CAVICN have provided a standards-based foundation for heterogeneous networking of many devices on many physical networks for diverse purposes, and quality of service and failover guarantees appropriate to support human health and safety. Accordingly, commercial, industrial, military and other institutional users now use systems that differ from home systems mostly in scale. See home automation for more on entry-level systems, NVOI, 1905.1, and the major proprietary vendors who implement or resist this trend to standards integration. Almost all multi-story green buildings are designed to accommodate a BOS for the energy, air and water conservation characteristics. Electrical device demand response is a typical function of a BOS, as is the more sophisticated ventilation and humidity monitoring required of tight, insulated buildings. Most green buildings also use as many low-power DC devices as possible, typically integrated with power over Ethernet wiring, so by definition always accessible to a BOS through the Ethernet connectivity. Even a passive house design intended to consume no net energy whatsoever will typically require a BOS to manage heat capture, shading and venting, and scheduling device use.